Okay, the test for this unit could be over stuff that has the stars and stuff we haven't tested yet. So most importantly, making sure that you still know the major definitions. I'm not going to test you again on walk, path, trail, circuit, but making sure that you still know what it means to be the degree of a vertex, the order of a graph. Okay, those kind of things are still really important words. So making sure that you know those words. Also, the length of a path is the shortest way to get between two vertices. Okay, so some important definitions that could still show up then are order, degree, and then being able to locate the length between two vertices. And the length between two vertices is the shortest way to get from one vertex to another vertex.
What's the order again?
The order is how many vertices are in the whole graph.
Okay. And what was the last word?
Length.
Wait, what's degree?
The degree is how many edges are coming out of a vertex, or how many other vertices it's connected to, if it's a simple graph. In general, it's how many edges are coming out. I am not going to test these other three again. So those things we tested sufficiently on the quiz. The vocabulary is important though, because if you don't know vocabulary, you can't really answer questions. So that's why that one's making a reappearance.
He shouldn't be.
Digraphs.
Oh, they're picking up still.
Digraphs are used to show power. So we had problems that were about influence. This person influences another person. They could be used to show conversation flow. So we had questions about like gossip and how information travels in a group. They could be used to show direction, like in a map. If it's a one-way street or a train or airplane route that only goes in one direction. So being able to follow a digraph, showing influence or connections between certain people that goes only in one direction. So look over those problems again. Problems similar to the homework problem will be there. So if you look over your homework problems from the digraphs, that will be something similar to one of the homework problems. Scheduling. Scheduling will be there. You should be able to make a PERT diagram. So the PERT diagrams, get my screen to move. The PERT diagrams are where we say we begin with a time of 0. And then from there, what task can we do? I could do task 1, and maybe that one takes 2 weeks. And I could do task 2, and maybe that takes 4 weeks. And I could do task 3, and maybe that one only takes 1 week. Then maybe task 4 is dependent on tasks 1 and 2 being done. And maybe that one takes only 1 week. Okay, and we create out that diagram based on what needs to be done from one level to the next based on their prereqs. Then you should be able to make the schedule. Okay, the schedule is where you would say, in our week, what tasks are we doing? So in week 1, I can start anything that does not have a prerequisite. So in this little partial PERT diagram, in week 1, I could start tasks 1, 2, and 3 because none of them depend on anything else being done. Task 1 is going to take 2 weeks, so it needs to keep on going. Task 2 is going to take 4 weeks, so it needs to keep on going all the way through the 4th week. Task 3 is only going to take 1 week, so I'm done with that one. Task 4 cannot begin until task 2 is done. So task 4 cannot begin until that 5th week because it needs tasks 1 and 2 to be done. And we would continue on out and see by the time everything is done, how many weeks did our schedule take us. questions on that? Yes.
Do we need to know like critical path and longest path?
The critical path is the longest path, but no, your critical path will be the same as charting out a table.
Okay.
It's just a little bit easier to be certain of your answer when you chart out a table and a schedule, other than to know for sure, especially in a really messy graph, to know for sure you actually found the critical path. You would really need to trial and error all of it. So making the weekly schedule is a faster way to the same answer. And then the last topic is graph coloring. So being able to make a graph, remembering again that when you make a graph, your vertices are the things you are trying to schedule. Okay, so like in our example in class, we were trying to schedule movie show times. So the movies were our vertices. In some of the homework problems, trying different groups to go to the zoo. So the groups were our vertices. Whatever you are trying to schedule is your vertices, and you connect them if there's a conflict. Okay, so if two people want to do the same movie or activity, or if two species can't live together or they will eat each other, then whatever our conflict is going to be a connection, because that will force those two things to be a different color. Okay, so whatever you're trying to schedule is your vertex, and you connect two vertices if there's a conflict between them, so that they will have to be done in a different color. And then being able to make a schedule from that and say that on day 1 this can happen, on day 2 this can happen, on day 3 this can happen.
How do you do the schedule? Like, how do you draw that?
It's really pick and choose. I mean, you get to decide who's going to go on day 1, but the important thing is you would just say like day 1, and then like our problem in the homework was different groups that were going to go to the zoo. So it was like an elementary teacher trying to plan a field trip. So on day 1, she could really choose whatever group she wants to go. So maybe group 1 would go because that kind of makes sense. And then if somebody else can go with group 1, they would also be on day 1. But maybe that group has to go alone. So that'd be the only thing that happens on that day.
Basically, think about it like they won't collide at the zoo
Right.
if.
Right.
Okay.
So yeah, that one was about like feeding animals, and we can't feed the same animals more than once a day, or they're going to get really fat. So we'd have to make sure that the same animals aren't getting fed more than once. So on day 2, maybe group 2 could go, and maybe group 5 could go with them because there were no conflicts, and that kind of thing. Okay. All right. That is all. I didn't come up with a brilliant mandate connection. Did anybody else? Yeah. No. Yeah.
Not for the mandates,
I
but
was so excited.
do you want us to know about like directed paths for digraphs?
Digraphs and directed paths are the same thing.
Oh.
Digraph is just a graph that has direction, and then a directed path would be like following through a digraph, so you're not going the wrong way down a one-way.
Okay. So like if it asks the question like, is this a directed path?
Mm-hmm. So it just means like, does it follow the arrows, or is it creating a conflict of direction?
Okay.
All right.